Moving forward, an operating system is a program that controls the execution of application program and acts as an interface between the user of a computer and computer hardware. So in graphical representation, as you can see, user is placed in the front end and hardware is placed in the back end. So these two, user and hardware, will interact with each other with the help of operating system. It also manages memory, processes, files and security, which means in memory, whenever we give some command to execute something, it will retrieve from the memory and then it will execute. So for that it has to manage memory. And then next is processes. Whenever we give some command to the computer, OS generally makes it in a form of program, and that program is placed under processes and then it is executed. So program is nothing but it is a set of instructions which we generally give to the system. And next is file. File is nothing but we generally store in the system. That is nothing but that as a whole it can be considered as a file. And then next is security. Security is nothing but this is the protection of data. This is the protection of data which will be provided by the OS. Next is goals. So in OS we have two goals, primary and secondary goal. So we have seen different kind of computer system. The system we use in our home purpose is PC, and the system we generally see in the scientific purpose is mainframe or supercomputer. So in both the cases there is convenience and efficiency. So in our case, convenience is our primary goal and efficiency is our secondary goal. In a similar way, in case of a scientific purpose computer, efficiency is the primary goal and convenience is the secondary goal. The reason behind is, in our case, uh, the PC we use, we generally expect user-friendly software rather than complex software. So for that reason, convenience will be our primary goal and efficiency will be our secondary goal. In a similar way, in the case of scientific purpose computer, so the organization might expect accurate computation. So for that reason, it has to focus on the efficiency. So that is the reason it is the primary goal, efficiency is the primary goal, and convenience is the secondary goal. Next is evolution. The evolution of operating system is directly dependent on the development of computer system and how user use them. Likewise, in the backdate, there was development of ENIAC, that is Electronic Numerical Integrator and Computer. So it was the first general purpose digital computer, and it was able to solve large class of numerical problem. So likewise there was so many development, and recently we are aware of this Android OS and iOS, which is of Apple. So these are the evolutions of the OS. Next is generation. So in the first generation, from the year 1945 to 1955, vacuum tube were used. In the second generation, 1955 to 1965, transistor were used. And in the third generation, 1965 to 1980, integrated circuit were used, and it was capable enough for multi-programming. And in the last generation, that is fourth generation, from the year 1980 to present, this is personal computer. So the system which we are using is of fourth generation. Next is mainframe system. So in this system, first one is batch processing or batch operating system. So in this system, sequence of job in a program on a computer without manual intervention. So it means there is a CPU and then there is two job, J1 and J2. So first J1 will allocate this system and then it will execute and then it will give the desired output. And in the second case, J2 will come to this CPU and then it will execute and then it will give the desired output. So this is likewise J1 is done and then J2 will be executed. So this is how it works in the batch operating system, batch wise. So next is time sharing operating system. So here it says that it allows many user to share the computer resources, which means again the same thing, again the same situation. There is a CPU, there is two jobs, J1 and J2. So first J1 is executing this part, this computation, and then at the same time in between this execution of J1, J2 might get into the system. So in this case, in this system, it allows J2, and then first it will hold J1 and then it will execute J2. So likewise it will operate in the time sharing operating system. So next is multi-programming. So in this system, as the name suggests, it is multi-programmed. Like so this system allows you to do the more than one job. That is, you are running Excel, at the same time you are browsing something in your Firefox browser. So this kind of jobs, or this kind of execution, can take place in the multi-programming system. Next is multitasking. So in this case, in this kind of system, there are a concept of multiprocessor. So multiprocessor is nothing but, in a system there is more than one processor. Suppose let us say P1, P2 and P3. There are three processors in a system, and similarly there are J1, J2 and J3. There are three jobs which need to be executed by the system. So in this case, J1 can allocate this P1, J2 can allocate this P2, and J3 can allocate this P3. So in a parallel fashion it is executing, so obviously the result will be more efficient. So this is nothing but concept of multitasking. Next is multiprocessor system. So in this system, multiprocessor system which provides processing using more than one central processing units. That means here you can see in the diagram there is more than one processor, CPU 0, CPU 1 and CPU 2. It is not that it has to have a physical CPU, more than one cabinet. It's just the concept that in one CPU, in one physical CPU, it has a multi-processor capability, which means I hope you people have heard about multiprocessor, quad processor, or octet processor, which means in quad processor it has four multiprocessor, in octet it has eight multiprocessor. So likewise, so this is the concept of multiprocessor. So as I've already discussed earlier, that whenever you have certain jobs, it needs to perform, suppose J1, J2 and J3. So in this case, J1 will be executed in CPU 0, J2 will be executed in CPU 1, and J3 will be executed in CPU 2. So this is the main advantage of the multiprocessor. Next is distributed system. It is a system, it is a collection of independent components located at different machines that share messages with each other in order to achieve common goal. So right example would be ATM machine system. So if you are taking some amount of money from branch B1, and after taking money you will find account details, like you have this much of balance and then and so on. At the same time, if you come back to branch B2, and if you go back to the same thing, same process, and if you take the same details of your same account, then you find the same details which you have fetched from branch B1. So this is happening because of the system which is implemented in the banking system. So the system which is known as distributed system. So next is cluster system. So in this system, cluster computing is the process of sharing computation tasks among the multiple computers, and those computers are machines from the cluster, which means in this system all the computer, whatever the system you have, it can be connected in the network through different topology. So here I have given example of LAN. So LAN is the topology of network which can be implemented in this system. So here computer 1 can communicate with computer 2, likewise it can communicate with computer 3, vice versa. So if you have any files, and then if you want to access from computer 2, then this is possible in this system. So next is real-time system. So in this system, processing must be done within the defined constraint, which means, so here I have given the example of defense sector. So in defense sector, if that particular organization is planning to drop some missiles in particular certain geographical area, so it has to be scheduled in a given time frame, and it has to be scheduled in a particular geographical area, and this can be achieved with the help of real-time system. So next is special purpose system. So in this system, it will do specific tasks. Like for example, if we go to any food processing manufacturing unit, there might have packaging unit, there might have labeling unit. So in this way, it will do specific tasks for each unit. So this can be achieved by the special purpose system. Next is open source operating system. So in this system, it is a software with source code that anyone can inspect, modify, and enhance. So here I've given the example of Ubuntu. Ubuntu is nothing but it is a operating system where user can inspect, modify, and enhance according to their need. So it is open to all. So therefore it is known as open source operating system. So after attending this lecture, what you have understood, please answer these questions and make a note out of it. Next is, so these are the resources I have used while preparing this slide. And lastly, thank you.